Hello everyone, hope all of you are doing great, and in today's video we are going to discuss lesson 5.2, interior angles of polygons in the workbook. Alright, so the first question here says to you that work out the sum of the interior angles of a polygon with 4 sides, 8 sides, 12 sides. We're going to do one of them. Let's choose, for example, here 8 sides, and the rest are exactly the same. I'm going to show you how even to do the rest. Alright, so we learned that the rule to find the sum of the interior angles of any polygon, the rule is n minus 2, you multiply by 180 degrees. So let's do this. 180 degrees multiplied by n is the number of sides. They told you it has 8 sides, which means it's an octagon. So 8 minus 2. So it is 180 multiplied by 6. Multiplying 180 by 6 is going to give you exactly 1080 degrees. Okay, mister, if I want 4 sides, just to remove the n and instead of 8, write 4 and do the same calculation exactly. I want 12 sides, just remove the n and write 12 minus 2 instead of 8 minus 2 and do the rest of the calculations exactly the same way. Question 2a says to you, show that the sum of the interior angles of a pentagon is 540 degrees. Okay, a pentagon has 5 sides, so I'm going to say the sum of the interior angles of any polygon is n minus 2, and you multiply by 180 as we agreed. They said pentagon, so 5 minus 2, you multiply by 180. So 3 times 180 is going to give you 540 degrees. Now I found the sum of the interior angles of a pentagon. Question B says to you, 4 of the interior angles of a pentagon are 120 degrees each. I know that they did not write the word each over here, and I personally find it also confusing without the word each. They were supposed to write it. I agree with you, but actually it's not going to be possible if it's not each. So 4 of the interior angles of a pentagon are 120 degrees each. Work out the fifth angle. Mister, I know that the 5 angles, all the 5 angles are what? Are 540. 4 angles are 120 degrees each. So 120 times 4, which is 480. Find the fifth angle. The fifth angle, how can I find it? It is 540, which is all the 5 angles together, but you minus from it the 480, and it's going to give you 60 degrees exactly. Let's continue. Question C. 4 of the interior angles of the pentagon are 108 degrees. Is it a regular polygon? So here also they mean 4 of the interior angles of a pentagon are 108 each. So let's see, mister, the interior angle of a polygon, a regular polygon is what? We learned that the size of the interior angle of a regular polygon is found through the rule n minus 2. You multiply by 180. Mister, isn't this the sum of the interior angles of a polygon? Yes, but if you want one interior angle, you divide by n. Pentagon, mister, we want 5 minus 2 is 3. Multiply by 180, 540. I just did the calculation mentally. Over n, we said it's 5. And the number of sides of the pentagon is 5 sides, equals, you're going to find 108 degrees. Oh, mister, the 4 angles are 108, and the fifth angle, you're going to find that it is 540. We said that the sum of the interior angle of a regular pentagon is 540 minus the 108, but they are 4 angles, right? They are 4 angles. So 108 times 4, minus it from the 540, it would give you the fifth angle. You're going to find that it is also 108. It is a regular polygon, mister. All the 5 angles are 108 degrees, mister. So it is a regular polygon. All the 5 angles are equal. Next, question 3. A nonagon is a polygon with nine sides. Work out the sum of the interior angles of a nonagon. The same technique exactly. N minus 2 times 180, but n here is 9 minus 2 times 180, which gives you 7 times 180. It is going to give you exactly here 700, 560, 1260 degrees, 1260 degrees. Work out the interior angle. They want only one angle of a regular nonagon. Mister, it is the same. It's 1260 degrees. اللي هي n minus 2 multiplied by 180 over n. N here is 9, the number of sides. So it's going to give you exactly 140 degrees, 140 degrees. I did the division mentally. So it is 140 degrees is the size of one interior angle. Here, the sum of the interior angles of a polygon is 900. Okay. How many sides does that polygon have? Mister, oh, I know that the sum of the interior angles of any polygon is n minus 2 times 180. They're telling you that this is equal to 900. Okay. So what are you supposed to do? I'm supposed to solve the equation. It's algebra right now. Find the value of n. What is the last thing that happened to n? You're going to find that it got multiplied by 180. Send that multiplied by 180 their division. But n minus 2 equals, you're going to find exactly that it is 5. 900 divided by, let me just remove this also to write the step for you. 900 divided by 180. I sent to the multiplication there, division. N minus 2 equals, you're going to find that the answer to this is 5. So n equals 5 plus 2 is 7. So what is that shape? It is a heptagon. It has, they ask you, how many sides does the polygon have? You write 7 sides. Marcus says, here we go. I have drawn a polygon. The sum of the interior angles is 800. Explain why this is impossible. Well, Maserwa, I know that n minus 2 multiplied by 180 gives me the sum. He said the sum is 800, right? If I find a shape with, for example, 7 sides, that is 800, then done. 8 sides, then it's possible. 9 sides with 800, then it's possible. Any number of sides that is a whole number, like 6 sides, 7 sides, 8 sides, 10 sides, and it gives me 800, then it is possible, Mister, to draw a polygon with 800 degrees for the sum of the interior angles. But if n becomes a decimal, that means, well, 6 sides and a half. Well, that's impossible. There is no such a thing, as if you're saying 7 people and a half. No, that doesn't exist also with the number of sides and shapes. So let's now do the multiplication, solve the equation. N minus 2 equals, you send it 180 over there with division. You're going to find that it is a decimal right away. Right away, you're going to find that it is a decimal. Look at this, 800 divided by 180 equals 4 point a lot of fours. So 4.4 and a dot notation. So n is 6, because I'm going to send the negative 2 there, plus 2. So 6.4 dot notation above the 4. So it is impossible. Impossible. All right? Okay. The next question, question 5 over here. What mistake has Sophia made when she said that there are 6 right angles in this hexagon? So the sum of the interior angles is 6 times 90 degrees. She wants the sum of the interior angles. Well, Mr. Hoa, there are 6 right angles, and she's correct, but one of them is exterior. Look at this. This right angle here is exterior, it's not interior. But this, yes, interior, 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 interior. But this one over here, This is now the sixth angle. This is angle number six. We need to find it. So, what mistake has Sophia made? Sophia counted the exterior angle as one of the interior angles. This is all what you just need to write. Question 7 here says to you, work out the sum of the angles of this shape. Well, mister, we know that the sum of the angles is n minus 2 multiplied by 180. But how many sides is this shape I have here? Let's start. 1, 2, 3, 4, 5, 6, 7. 7 sides. This shape is 7 sides, so it is 7 minus 2 multiplied by 180, which is 5 times 180, which is going to give you exactly 900 degrees. Okay, that's question A. Question B says to you, work out the value of x, this angle. Well, mister, well, I know that this is 90. Good. So I got here, how many 90s? This is 90. 90 plus 90 again, and I have this 70, and I have that this. Now I wrote 4 angles. I have 3 angles missing. This one is a reflex angle. Part of it is 90. The other part, how can I find it? 360 minus 90, which is going to give you exactly 270. So plus 270 degrees plus this angle, the rest of 120. So 360 minus 120 is going to give you 240. All of this, I have 1, 2, 3, 4, 5, 6 angles. But semester, there is one missing, which is the x exactly. I found that the 7 angles together add up to what? The 7 angles, we found that the sum of the interior angles, the 7 angles are 900. So it is 900 minus the 6 that you have, which is all of this, will give you x. So x equals 900 minus all the 6 angles that we have. So let's do the calculations. 900 minus 90 plus 90 plus 90 plus 70 plus 270 plus 240, close the brackets, equals 50 degrees. So x is 50 degrees exactly. Question 9a. It says to you, show that it is possible for 2 regular octagons and a square to fit around the point as shown in the diagram. Well, for fitting around the point, to fit around a point, the angles around the point add to 360 degrees, like in this one over here. Look at this one. Here is the point. If you prove that this, which is 90 degrees, and this, and this, they add up to 360, so they fit to be around the point. Look at this. The angles around the point add up to 360 degrees. This is the most important rule. If you take care of it, you'll be able to solve any question that includes angles around the point. Angles around the point are 360 degrees. Now let's prove this. One interior angle in the square We know that it is 90 degrees. So here is this angle. Thank you. 90 degrees. One interior angle inside an octagon, because they told you this is an octagon. They said, oh, here, octagons. So inside an octagon, oh, how can I find this one interior angle? We know the rule. N minus 2 times 180 over n. Following the rule, 8 minus 2 is 6. So 6 times 180 is going to give you exactly 600, 1080. We've just found the interior angles of an octagon. 1080 over 8 is going to give you the sum, is going to give you the size of one interior angle. So we said 90 is one interior angle in a square. One interior angle in an octagon is 1080 divided by 8, which is going to give you exactly, here is going to give you 1. Here we're going to have 3. And after that, we got a 4, it's 5. So 135 degrees. Mister, that's the interior angle of what? An octagon. But we have, Mister, two octagons. Look at this. This is one interior angle in an octagon, which is 135, and one interior angle of another octagon, which is another 135. Add the three of them up. Will they give you 360? Let's do it. So 90 plus 135 plus 135. Yes, mister, if you add them up, they will give me exactly 360 degrees. And that's how I show them. This is what they're going to look for. They're going to look for this. 90 is the interior angle of the square. 135 is the interior angle of an octagon. 135 is the interior angle of the other octagon. So adding them up gives me 360. Now you showed that they can be rearranged around a point, or they can fit around a point. Here, next question says to you, show that it is possible to arrange a mixture of regular hexagons and equilateral triangles around a point. Mister, هو equilateral triangle, which means a regular triangle, which means that the three angles are equal. The one angle is 60 degrees. One angle only is 60 degrees. What about a hexagon? Hexagon, one angle in an hexagon, one angle, Mr. n minus 2, we're going to follow the rule. So we said here the 60 degrees, n minus 2 times 180 divided by n, which is 6. So 6 minus 2 is 4, Mr. 4 times 180 is going to give you exactly 720. So 720 divided by 6, you're going to find that it is 120 exactly. 120 degrees is one angle of a hexagon. They are asking you to show that a mixture of hexagons with equilateral triangles can be rearranged to fit around a point. Fitting around a point? Around a point, Mr. Ahmed said, means 360 degrees. So if I have two hexagons and one triangle, okay, two hexagons, I'm sorry, and the two triangles, that will give me the 360 because two hexagons are what? 120 and 120, 120 times 2, which is 240, plus two triangles, 60 times 2, that will add up to 240 plus 120 is 360 degrees. So, Mr. Having two hexagons and two triangles, they will fit around the point. Two hexagons and the two triangles that will fit around the point. طب مستر هو I could have how could I find out about 2 and 2? It's trial and error actually. So you could have started with the least number of hexagons. So one hexagon, if we say one hexagon and three tri triangles. Well, let's see first. One hexagon is how many degrees? One hexagon الانتيريور angle الواحدة, one interior angle is 120 degrees. How many are left to reach the 360? 240. So 3 will not actually work. I need here 4 triangles. 4 triangles, which means what? 4 times 60. 4 times 60. Look at this. Because one interior angle is 60. So 4 triangles, each one of them is 60 degrees. Each angle, interior angle is 60 degrees. That will add up to 240 degrees. So 120 and 240 will give me 360. So, yeah, mister, I can have a mixture of hexagons and triangles to fit around or to be rearranged around a point. Yes. All right, how they will add up to 360 at the end, that's what I need to find. The number of the interior angles around the point must add to 360. How many ways can you do this? I can do it in 2 ways, either 2 hexagons and 2 triangles, or 1 hexagon and 4 triangles. Both will give me the 360. So 2 ways. This is question II. Let's see if they considered having no triangles. Just a second. This is question 9 BII. So question 9 BII, here they said there are 3 ways. They said it. Actually, 1, 2, 3, 4 triangles. 4 triangles and 1 interior, 1 hexagon. This will fit around the point, so it will work. So here is the one that we said. 4 triangles and 1 hexagon. There are also here 2 triangles and 2, oh yes, 2 triangles and 2 hexagons. That's what we did here. 2 hexagons and 2 triangles. We did this, and it is saying also 2 hexagons and the 2 triangles, but rearranged differently. So 2 hexagons and 2 triangles again, but they are rearranged differently, as you see, shaping or making a different shape. Sorry. All right, here. Next. Question 10 says to you, work out the sum of the interior angles of a decagon. The sum of the interior angles of a decagon. Let's do it. I have a Mr. The rule. N minus 2 multiplied by 180 degrees is going to give me the sum of the interior angles of any polygon. I have a decagon. I know that the decagon is 10 sides. So follow the rule. You're going to find that it is 8 times 180 degrees is going to give you exactly 1,440 degrees. This is the sum of the interior angles of a decagon. All right. This diagram shows 2 regular pentagons and part. So now we answered to question 10A, okay? This answers question 10A. This diagram shows 2 regular pentagons. Regular pentagons. We found that the angles, the sum of the interior angles of the pentagon is 540. Divided by 5 is going to give you 108 degrees. So we know now that the interior angle of a pentagon, a regular pentagon, is 108 degrees. Mister, I forget. No problem. Follow the rule. N minus 2, where n is 5. N minus 2 times 180 divided by n will give you 108, where n is 5, because I have 5 sides here for the pentagon. So the interior angle here is 108. This is 108. What is this going to be? What is this angle going to be? I'm going to do it here. Mister, I know that the 3 of them add up to 360 minus 108 and 108 will give you exactly what? 360 minus 216, which will give you exactly 144 degrees. They want you to show that the third shape is a decagon. The shape that is missing over here, only part of it is shown. They wanted to show that it is a decagon. Well, mister, they said that it's a regular polygon. If I find out that one interior angle, this missing angle here, we found that it is 140 degrees. If I prove that that one interior angle in a decagon as they requested here is 144 degrees, then this is a decagon. So what are we supposed to do here, mister? You are supposed to, just a second. I'm gonna need to stop using the pen, stop inking. Here we go. Just the space. All right. So here we said that n minus 2 multiplied by 180 over n will give me one interior, right? If the one interior, when I say that this is a decagon, they want you to prove that it's a decagon. So n is 10. 10 minus 2 times 180 over 10 equals 10 minus 2 is 8. 8 times 180. You're going to find 1,440. Divided by 10 is going to give you one interior angle is 144 degrees. So I proved that this interior, this polygon, is actually a decagon because I found out that this is 108 degrees, one interior angle in a pentagon, and this is 108 degrees, the other interior angle of the other pentagon. And I found out that the third angle, it's around the point, which is the three of them add up to 360. I found that the third angle is 144. And I also, the fourth and the last step is to find one interior angle in a regular decagon is 144 degrees. So this is definitely, the third shape is definitely a decagon. Okay, here. In this example, question 11, they're saying to you this star has 4 lines of symmetry, which means that these angles are actually equal. That's what they want to say to you. These angles are exactly the same. And also this is the same as this, the same as this, and the same as this. This is what they mean by saying that it has 4 lines of symmetry. These 4 are equal, and the other 4 over there are also equal. Okay. Work out the angle of each point. And also, it has a rotational symmetry of order 4. That's the same thing exactly. It says to you the same thing. Work out the angle of each point, which means this. The angle of each point. Mr. Well, I know that this is 180, 120. This is 120. So this x is how many degrees? 360 minus 120 will give you what? 240 degrees. So, mister, I know that the x is 240. This x is 240 degrees. I have 4 of them, right? So it is 240. Now we found the 4 x's, but we could not find yet the other 4 angles that they're looking for. How can I find it? First thing that I need to find is the sum of the interior angles of this octagon. Oh, octagon, mister? Yes, it is an octagon, we said, because it has 8 sides. Okay, so now it's going to be what? I'm going to find n minus 2 multiplied by 180. That will give me the sum of the interior angles. So 8 minus 2 is 6. 6 multiplied by 180 is going to give you exactly 1,080 degrees. Okay. All the 8 angles are 1,080. 4 of them are 960. What are the other 4? Okay, mister, the other 4 are going to be 1,080 minus 960, these 4 x's, is going to give you exactly what? 120 degrees. Mister, that's the 4 of them. Yes, they want each point. So 120 degrees, that's for each point. Each point is, I'm sorry because I'm doing it in a messy way because I don't have actually a copybook like you. You must have it and do it in an organized way. So each point is going to be almost 120. We found that the four of them are 120 degrees over four, which is 30 degrees each point. Okay. Again, just I'm not going to redo it again because you can actually replay this part. But I'm gonna just to sum it up for you, the plan and everything that we did. I just found that each x is what is 240 degrees because it's a reflex angle. So each of the four angles here is 240. The four of them together are 960. I minus the 960 from 1080. Where did you get Mr. 1080 from? I calculated the interior angles of an octagon, and I found that all the eight angles add up to 1080. That's why I minus 1080 and 960 to get the four other angles together. I found that the four other angles together are 120 degrees. Mister, they want only one. So 120 degrees divided by 4 is 30. The last question here. Let me just erase this. They say to you that this shape, this star, has inside a pentagon, a regular polygon, which is a pentagon. Here you go. That's what they're saying. They're saying that you work out the angle of each point of the star, which is this one and this. They want only the angle of each point. Mr. Roma, they said this is a regular pentagon, right? Yes. A regular pentagon has n minus 2 times 180 over n. And I give the size of one angle, Mr. One angle only. So n minus 2 times 180 over n equals. You're going to find that this is going to give you exactly 540 over 5, and it's 5 is going to give you exactly 108 degrees. Mister, this is 108 degrees. Here you go, mister. This is 108 degrees. How will this help me? It will help you a lot. If this is 108, what is this? Okay. And this is also 108 degrees. What is this? Fine, fine. Okay, let's do it. So this is 108. The other is supplementary with it, supplementary to it, which means they add up to 180 degrees. This is 108, then the other is 72 degrees. This is also 108, so this is 72 degrees. So what is the third? 72 plus 72 is going to give you 144. The third is going to be, here, let's go, 180 minus 144. I got 72 and 72, which is 144, equals 36 degrees. That's it. No, we have one more question. I was going to end the video. All right, so the saying to you here, Zara says, an expression for the sum of the interior angles of a polygon with n sides is 90 multiplied by 2n minus 4 degrees. They're saying to you that this is an expression that you can use to work out the interior angles of a polygon. Now we learned that the interior angles of a polygon is n minus 2 multiplied by 180. Yes, yes, but she's just trying to work out another expression. Okay, so what do they want from me? Test this conjecture. Oh, Master, I do not understand. What do they mean? They just mean test this expression. Is she correct or not? Can this be used to find the sum of the interior angles of a polygon or not? Test it. Okay, she's saying 90 multiplied by 2n minus 4. If the polygon is مثلا, for example, let's say that polygon is a triangle. So will it be, if I remove n and write 3, will it give me 180? Let's see. Test on a triangle, which is 3 sides. Let's do it. Equals 90 times 2 times 3. 2 times 3 is 6. 6 minus 4 equals 90 times 6 minus 4 is 2. Oh, Mr. Yes, 180. So she is right. She is correct. I tested her conjecture. I tested her expression that she provided to find the sum of the interior angle of any polygon. That's it. Thank you so much and see you in another video.